Okay. I just need to make space on the hard drive. All right, so the first thing I want to do is value at risk. And those are just on the slides which you see, but people watching the video don't see. I'm going to put those up in a bit because I want to concentrate on the stuff I'm going to write down here for a second. Because I want to think about value at risk. In the end, you're going to look at it and go, well, that's an easy, straightforward concept. But at the beginning, I find that sometimes students you're going to try to make more of it than it is. So, value at risk. There's a whole chapter on it, abbreviated VAR, and it's an estimate. Estimate is a key word here because it's a back of the envelope ballpark type calculation. So it'll look like a rough approximation because it's an estimate. It's like, yeah, and this is the thing that particularly math students have a problem with because we can do a way better job with getting this number. But this is an industry sort of way of getting the back of the envelope calculation. It's an estimate of how much a portfolio can lose in one day with a confidence of, I don't know, like 95%. So these things are kind of modular though, right? This percentage here and this one day. That one day, that's the time horizon. And that 95%, that's your level of confidence. So you can say things like, I'm 95% sure that this portfolio won't lose more than $400 next week or in a week. That's the kind of statement that you get to make. So it's totally not a promise. It's an estimate. In fact, if you're 95% sure that you're not going to lose more than this amount of money, and it shows up, 5% of the time that's going to happen. That's 1 out of every 20 days. It's like once if you do business days, that's once a month you're going to be wrong. So it's a very rough calculation, but it's used to just sort of as a quick way to sort of backstop, right? So if someone says they're 95% sure that your portfolio is not going to lose more than $400, and you sort of like have an extra $400 like kicking around your sock drawer or wherever you hide money, then you feel like, I'm okay, right? I can cover that. So some things to think about. Value at risk is for normal conditions. Now that word normal carries a lot of weight there. By normal, I mean both typical conditions. So if the market is crashing or there's some kind of catastrophe, or if something's booming because, I don't know, suddenly COVID is cured, then this doesn't work. So it's for normal, regular conditions. And I think also normal because I'm thinking specifically about the normal curve. Our returns for stocks come out of a normal distribution whose average is mu dt, so an expected return scaled with time. So if I change this from 1 day to 1 week, my dt changes from 1 over 252 to 1 over 52. And the standard deviation of the normal curve that we're picking out returns from, if you think about it, I'm picking a return out, and the expected return is mu dt. Our standard deviation would be sigma root dt. So that's giving me some measure of the spread of this returns. If I'm thinking about 95%, then that means I want to have 5% in the tail here. So I just need to, this is actually going to be the whole deal, John, in this one picture. I just need to figure out what's the Z score that puts 5% of the tail, and a Z score is equal to the score that we get, so the actual return you get minus the expected value, all divided by the standard deviation, right? Excuse me. So if I get this Z score, and for 95%, that's minus 1.64. So I'm going to need to look that up on the Z table in the back of a textbook, or I guess now we would just look on the internet. But those are sort of standard scores. And if you were always quoting 95%, that 1.64, you just like, it would be a number that you would just know. And so I could figure out what the X is from this. There's your value at risk in a picture. So the first thing, so these are the returns on a stock. I'm going to, that's what I'm saying for normal conditions, because we're thinking about taking the returns from our normal distribution. I'm going to make some space here because I'm writing on this board. The normal conditions is going to go. I'm going to redraw that picture in a bit. But there's some things I got to think about first before we think about what's our money that we can lose. We need to know how much money we have. So, I'm running through all my money. So you need to know the value of your assets. Well, this seems like a rather trivial question, right? But it's not. It is for some things. So for things like stocks, yeah, that's easy. How do you know how much your stocks are worth? You look them up in the market and see what you could sell for. So you look them up in the market, they're traded, so that's called mark to market. So things that are liquid, you could just see what you could sell them for, a mark to market. If it's an option, calls, puts, stuff like that, you could mark to market if they're liquid. If it's something, if an option that's very much traded, you could, but we could also use things like we could use the Black-Scholes equation, and that's mark to model. So mark to market, mark to model, these are accounting terms. To see how, just sort of like, basically you say, this thing is worth $3,000, and they want to know, how'd you figure, like, where'd you come up with that? Mark to market, mark to model. Basically saying, this is what this liquid item is traded for, or saying, I used an equation, a model, and this is what the model says it's worth. Now, I picked the two easiest things here. What if your asset is like commercial real estate or intellectual property or something like that, or goodwill, right? Because you're a celebrity and you're, the thing of value is the fact that it's just you and your name. How do I figure out how much that's worth? That's harder. So it's not always a super straightforward, but right now we're just working with things that are easier to figure out. So our big assumption which we know is wrong even before I even write it down. The returns of the asset, the returns are normally distributed. That's our big assumption. And I'm going to then redraw that picture. So me writing down here, I need to know the value of the assets, seems rather obvious, but it's not so easy, right? That's why you call in accountants when you have a more difficult portfolio to figure out. How much is your factory worth, your machinery worth? There's depreciation. You got to know how much. So, but we're just going to work with stocks and options. So, first thing is value at risk for a stock. The stock has a drift of mu and a volatility of sigma that we get in the standard way. Oh, and it also has a value of S. So those are sort of the data, the information that I can get from a stock. So if it's a standard deviation of the returns, that's the first thing I got to think about. The standard deviation for the returns, if we're talking about over a day, then that's sigma S 1 over root 252. That's the standard deviation of our returns. If it's a week, sigma S root 1 over 52. If it's just dt, sigma S root dt. So by assuming that the returns are normal, we've got so these are in dollars, because the whole thing, the value at risk is supposed to come out to so many dollars. We're 95% sure, we're 99% sure you won't lose more than this amount of money. So now I want to divide this up into this, I'm looking at it for a stock, but I want to divide it up into two scenarios, short term and long term. Again, these are estimates. So for short term, I'm going to ignore the drift rate for short term. And so, oh, that's a nicer market. It's like I'm thinking about the drift rate as 0. So if I want to talk about 95% sure, then 5% here is in the tail. If C is equal to, if the confidence interval is 95, I don't want to say confidence interval, that's a stat term. If I want to be 95% confident, then that corresponds to a Z score of minus 1.64. So our Z score was equal to the return we get, the X value, minus the expected value. In this case, we're just doing an expected value of 0, divided by the standard deviation. And so that gives me an X, and this Z is equal to minus 1.64. Squeeze that in. And so we get a value of the stock, the sigma, the root dt, and minus 1.64. But if it's short term, that dt, because we said it was short term, that dt is probably a day. Now, okay, this is a judgment call. Is a week short term? Totally depends, yeah. And it also depends on your motivation for quoting this back of the envelope type calculation. By ignoring the drift, I'm getting a worse answer. So it depends on whether I want my answer to be good or bad. But first off, where did the minus sign go? Well, we quoted as amount of money we're going to lose. So this will work out to be straight like dollars. So now I can look at an example here. So our first example, we got a stock. It's now worth 200 bucks. The drift rate is 0.06 and a volatility of 0.4. And I can calculate the value at risk. I've got the sigma 0.4, the value of the stock, the 1 over root 252, that's for the DT, and the 164, the 1.64, that has the 95% in it. That's 1.64 standard deviations. And I get an answer of $8.26. So in other words, I'm 95% confident that you won't lose more than $8.26 on a day with this $200 stock. How does that sit with you guys?
How do you get the confidence interval?
Confidence interval?
I mean, or the confidence percentage or whatever.
So when I say 95%, then I want the 5% to be in the tail.
I know, but how do you determine if it's 95%?
I pick the 95%. So I could choose 99%, like be more certain. Okay, if I'm going to be more certain, so I'm going to take that same example there, but I'm going to switch it to 99%. What changes? Well, if I'm 99% sure I won't lose more than that, that makes me put 1% in here. And so this value should get bigger, 2.3. Do I have that down here? I'd have to look it up on a chart. I don't want to do that, do I? I should have looked that up. 2.31. So the only thing that changes is that value. It gets bigger. That means the number gets bigger. So 95% sure I won't lose more than $8. 99% sure I won't lose more than, that number gets bigger. Does that make sense? I mean, the math says so, so yeah, sure, it makes sense because I trust what's written down. But does it make sense in my head? 2.58?
Yeah.
I'm going two-tailed. Thank you. So you didn't look up 99% though, because that, on a standard chart, sometimes that puts 1% here and 1% here.
Yeah, I looked up Z-value for 99% confidence.
Okay, thanks. So let's put that in. I'm going to switch this to be 2.58. Thanks for looking that up. And now $13. So I'm 95% sure I won't lose more than $8, 99% sure I won't lose more than $13.
Is this like the more confident you are, like the less precise you can be about how much money?
It seems like the more confident, the bigger the number gets to be, though, right? That's what I got to work out, like reconcile in my head.
Like an uncertainty principle.
Okay, I can do it this way. I'm 100% sure you won't lose more than $200,
Yeah.
right? Because that would be like the whole company goes out of business. So, as your confidence goes up, you have to give a bigger number because you're more sure. So you have to be more careful. Okay, that fits in my head. That fits. Like, I can internalize that as an idea. So now, what I'm saying about picking, there are probably, for the company that hires you to calculate these things will have standards. They always do 95%. Why would you want to switch to 80%? Well, that's going to make a smaller number, and that's going to sound better. So you need a balance between, and why would you want to sound better? Well, if I'm trying to sell some kind of a financial product, I want the risk to be small. I want to be able to tell my customers, I'm like 90% sure you're not going to lose more than $4. Then it's easy to sell because people will think, yeah, $4. I'll just skip lunch, right? I'll be fine.
So you just arbitrarily pick the percentage?
Well, so you can arbitrarily pick the percentage. So the company should have a standard and always use the same. Otherwise, you can arbitrarily choose. There's probably, for various industries, there is regulations, right? When you quote this in your prospectus, you always say 95%. But if there aren't any standards and there aren't any regulations, you can change that and make the number bigger or smaller depending on what you would like it to be. If I'm trying to sell you a financial product, I want it to be small. I want the confidence to go, like, I have to decide, would I lose a sale if I switch it from 90% to 95%? If the answer is no, then go with the 90%, and it makes your risk look smaller. If you're calculating it for yourself, then you could even, now this is not value at risk, but you could turn this calculation around and you could say, I've got a buffer of $20. So I can find the confidence interval the confidence level that would mean that I would not lose more than the $20 I have buffer. What happens if you're, like, this is for one stock. What if I own like 10 of these things? What if I own 10 stocks?
The drift of your portfolio?
Say loud.
Do you take the drift of your portfolio?
Well, okay, we haven't even taken drift into account, right? I've done short term, so I've assumed it would.
Or, okay, just take it like your whole portfolio, do it like that instead of doing it individually. Or do you have to do it individually?
Oh, I mean 10 shares of this company.
Oh.
So if I have 10 shares of $200 stock, each stock, I'm 95% sure, won't drop more than $8. I can just times that by 10. So it's just, if I have multiple shares, then the value at risk is done as a per share. That's short term. If I switch to long term, then I'm not ignoring drift, I'm taking drift into consideration. So then I'm adding in the drift, which would be mu s dt. Now that first the S's weren't in the original, the S's were not in the original normal curve that I drew because I was talking about returns. But now I'm talking about straight cash, like dollar changes. So that's why the return times the stock. So in this case now, when I go and solve for the X, the maximum, I'm going to end up with the expected return minus the 1.64 if I'm doing 95% times the sigma S root dt. So long term, I've got this extra little piece in here that's making it, oh, wait a minute. I got to make sure my signs are good, right? I think I'm good with my signs. So this drift will mute the negative here. I didn't have the negative when I was writing down short term because I was just talking about it being a loss. And now it's still going to be a loss, but the maximum loss could be a positive. If this is a positive number, then I'm not going to lose any money. So our example here on the slide, I'm 95% sure in a month. So I switched it to a month saying that was long term. So I have my drift in here, a 0.06. And when I work that out, I get 36. Oh, wait a minute. Putting in the drift was supposed to make it like the number better, because I was letting the stock, I was accounting for the fact that the stock was drifting up at 6%. Why is the 36? Why does it sound worse?
Because that's an entire month.
Yeah, that's a whole month. Okay, so there's another sort of standard that we can pick for quoting, right? If you want to make it sound good, pick a small time frame. If you want to make it sound really good, pick a small time frame and don't ignore drift. If I put that in at 252, if we were going to do days, yeah, now I'm only losing $7 instead of $8. If this,
Maybe I don't understand like the stats of the Z and stuff, but I feel like this is kind of a pointless absolute value of something. Like if you're not comparing it to the other value of risk of some other asset. Like if you're just looking at like the value risk of your stock and not comparing it to another stock, like it's kind of.
I don't think you can compare one. So if I'm using, I don't think I can use value at risk to compare two stocks directly. So let's say I have one. Let's go with the top example there. 95% sure, and I'm going to do daily. So I'm going to say that's short term. If I switch this to a different stock, then the different stock will have a different value. Let's say it's a $10 stock. And I'm going to keep the 1.64 here. So I'm going to keep them both at 95%. That seems fair. And this one has a slightly higher volatility. So it has a different value and has a slightly higher volatility. I'm only getting 50 cents. So if I compare the $8 worth of 50 cents, then I'm sure I could say it quickly and people would go, well, let's give me the $10 stock. That's less risk. Well, it's per share.
Could you do it like a percentage of the stock?
You'd have to do it as a percentage of money that you put in, right? So then you'd have to start. That's a way that you could compare. you'd say, I'd lose $8 on a $200 stock, or I'd lose 50 cents on a $10 stock, and then do it as a percentage loss. You could do that. It wouldn't be value at risk, because value at risk is in dollars. It would be like a percentage at risk, which is a thing, but it's not an official. Like value at risk in dollars is how the industry usually quotes stuff. Because you just want to, you're not so much comparing one stock with another. You're talking to your client who owns a portfolio of stocks. In our easy example here, they own like one kind of stock. And you're just telling them what's the worst case scenario. You're 95% sure this is, you'll do better than this. So we can see where we can swap out the time horizon and the confidence percentage. What's long term? What's short term? Judgment call. Judgment call, or it's written down in your official regulations of your company or the official regulations that the government makes your company follow. If you're doing it for your own portfolio, then it's a judgment call. I think if I was doing it for my own portfolio, I would think everything short term, because I wouldn't count on the drift. I would want to make it like a worst case scenario, so that I didn't get overconfident and suddenly lose all my money. Okay, so now there's a couple of things to think about. This is just one stock. And we said, what if you own like multiple shares of that same stock? Well, okay, then you just times it by 10 if you own 10 shares. So owning one type of stock, we get the value at risk. What if you own, which is more typical, a portfolio of stocks? So I've got some of this stock, some of that stock. Like we're back in chapter 21 trying to optimize that portfolio. By the way, final exam, going to be one of those on there, optimizing a portfolio. Going to be a value at risk question as well. Although the value at risk question so far would be super straightforward, right? So if it was a portfolio, if it was a portfolio of stocks, then it would be put together as the weight times the stocks. Well, I can deal with this, right? Because if I have a portfolio of stocks with the weight, then think about these formulas that are up here. Way up here. Okay, not that far. Oh, yeah, no. Here. I can get the drift of the portfolio as a weighted combination of the drifts of the stocks that I have. Those weights are the amount of money I have in each stock, invested in each stock. So it's the actual share price is kind of smoothed out there. And we can also calculate the standard deviation for the portfolio. So if I have a portfolio of stocks, I've already predetermined the weights. So my portfolio has a drift rate, and my portfolio has a volatility. And we're assuming that these are also connected to a normal distribution. So I could just use, after I calculate these values, I could just treat it like a stock, like a single stock, and use the regular value at risk stuff that I had before. So instead of this 0.5 being a stock, it would be the portfolio standard deviation. Our instinct would be that because when you diversify, you lower the standard deviation, you lower the risk, generally. So our value at risk should be better. The number should be smaller. Could a value at risk be a negative number? Yes.
I guess so.
Say loud.
None of options, I guess so.
Well, I don't have any options in here yet, though, right?
Yeah, isn't that kind of what we've been doing this whole time, like balancing portfolios in such a way that you can't lose, that you in theory can't lose money?
Yes, when we start to buy options and
Yeah.
hedge it, yes. But here in just stocks, if I were to do one of these calculations and come out with a negative answer, I guess I would have to interpret what I mean by a negative answer. Can you get a value at risk such that you're not losing any money? Yes, because if you have a drift in here, it could be that the drift part is so big that it overwhelms this negative piece. And so you would calculate this value at risk, you would get a positive number, and then that would mean that you would never lose money. Or you're 95% sure under normal circumstances that your portfolio won't lose money. It'll give you like your minimum gain, I guess. So if I think about this for a portfolio, now I'm happy with giving a value at risk calculation for a portfolio. And I do it with the data that I have that I would have used to optimize the portfolio. So my client, I can say, this is the mix of portfolio that you should have. I tell them the W's. And this is the value at risk, 95% sure. Just this quick calculation. So you'd be like, this is the best. You need to make this return. This minimizes your risk. And here's the value at risk for your portfolio, for the whole portfolio. At most, you're going to lose like $3. So that's sort of an output that you can give the guy, the purchaser. All right, one more idea that I want to talk about for value at risk here, and that's with options. So what about if you have options in your portfolio? So value at risk for options. Well, I know what the delta is. The delta, that's the amount of my option change for a change in the price of stock. It's a linearization of that. So if the stock drops $1, my option's going to drop $1 times delta in value. So the value at risk for, I just need to know what's the standard deviation. Now this is all short term. I don't want to do this long term because this delta changes as the stock changes and as time changes. So it's an instantaneous snapshot of what's going on. To treat it as a constant, it's a constant at an instant in time. But what does that mean? Everything's a constant at an instant in time. So I don't want to do this. I don't want to use this technique for like a week or something. A day I would be okay with. So then I just need the standard deviation. I just need the standard deviation to put into my value at risk. Well, that's all right. Well, this is the change in the value of the option for a change in the stock. The change in the value of the stock would be the sigma for the stock, the value of the stock, and then I would need my delta. and a root dt. And so my value at risk, I'm going to use this formula up here where I've got the sigma, or the standard deviation, which would be the standard deviation of the stock, the delta for my option, root dt, multiplied by the 164 if we're talking about a confidence interval of 95% or 2.58 if I'm thinking about 99%. So the only sort of modification is I want to know how many dollars the sigma s root dt 1.64 is the change in the stock, and the delta is the change in the option for change in the stock. So that gives me a maximum worst case scenario of how much money I would lose in owning one of those options. But this is not anything hedged. This is just like I bought a call. And it's a straight, rough, back of the envelope calculation. How does that sit with everybody? You can do way better. Like when I first learned about value at risk, I remember thinking, this is kind of cheap and yeah, this is really, it's really approximate. It's really, but it's a standard. It's a thing that they talk about in industry. So you want to be able to, when someone says something value at risk, you want to be able to go, yeah, I know how to do that. Also know it's not the best way to do it. It's just the way that they do it for straight back of the envelope calculation. It's like that rule of 72 we talked about, right? Take the 72 divided by the amount of years you need to double your money, and then that's your return. It's a ballpark, but we could do so much better. To do better, I mean, Monte Carlo or simulations, you could, there's a lot of different ways to do better. But now what I want to finish out today with is, let me go back up to here. When we were doing all these optimization things, in fact, all of the stuff that when we calculate, I always, in the questions on the midterm, right? The drift rate of the stock is, and I give you that. Or the volatility of the stock is, and I give you that. On the final exam, when I ask you an optimize a portfolio question, I'm probably going to give you the volatilities of the stock. I'm probably going to give you the correlation coefficients of the stock. Or if I don't give you the correlation coefficients of the stock, I'm going to give you the values of the stock like this. Right, so here's GM and Ford. Now I picked these, again, mostly because they're easy to spell, but they're both American car companies. So they should kind of move in unison, right? They're both big money makers, are full-size trucks. So if you're buying a truck, these are the ones you're looking at. Maybe Dodge, but like they should fare the same. Gas goes up, people stop driving massive pickup trucks. They both should drop, is what people are thinking. So here's the data as I've got a year's worth. These are daily adjusted closes. So if I wanted to give those calculations, let's say on the final exam, I needed to optimize a portfolio with those stocks. Well, I need the drifts of those stocks, the drifts. That's the annualized average return. So here are the returns as calculated, right? GM. On the 12th, it's $37.70. On the day before, it was 37 and 80 cents. Subtract it, divided by the 37 and 84 cents you put in, and I get that negative return. So I've got all the returns. These are daily returns for those two stocks. If I take the annualized average of the returns, I'm getting the drift rate of GM and the drift rate of Ford. It looks like nope. That's the drift, sorry, that's the drift of Ford because it's the average of the returns. This is the volatility of Ford because it's the standard deviation with the S, dot S, because I want to divide by n minus 1. Scaled by root 252 because it's daily. So if I was giving this as a question, I would say the mu of Ford is 0.076 and the sigma of Ford is like 0.558. That's what I would say. And we're all clear on how I got that number. But, okay, I took a year's worth of data here. That's a year's daily data. Daily data over a year. This other spreadsheet, though, oh, that's the same spreadsheet. Here's the same data. This is Ford, but this is weekly data. Get rid of the volume. So if I do the returns here, these are weekly returns, so they're going to be more because I get rid of that. But they're weekly returns over a year. So if I want the drift, that's going to be equal to the average weekly return and I got to scale it up. So I'm going to multiply it by 52. I'm getting a different number. That's my big point. So by picking daily data versus weekly data, I'm getting a different value. Quite a bit, actually, right? A percentage difference. And if I wanted that standard deviation, because I want to talk about the risk involved, so I want to talk about the volatility of Ford, I need to scale this up by the square root of 52. So if I use weekly data, Ford looks riskier by like 11% riskier. But it also looks like slightly more profitable. So the company might have standards. You always use weekly data over a year. But I guess I could have, like here I went all the way down, I took it over a year. What if I would have taken it over a portion of the year? I'm only going to 23. I'm only going to 23. Now I've got the same company, the same weekly data. Now I'm losing money and it's way more riskier. So even the easiest numbers, so I'm going to put that back, to a full year of weekly data. And I mean the average, that's the That drift, that should be like the most familiar, friendly formula. Add up all the numbers, divide by the number of numbers, right? Even that's giving me a different value. Notice that even though I switched from a year's worth of data to approximately half a year's worth of data, because the time in between these were taken was a week, I'm still multiplying it by 52. I'm still multiplying it by square root of 52. So the point of this sheet was, I'm going to go back to the other sheet, this drift and volatility here, we always quote it as, you know, this is the drift and I give you a number and that's the number. But you could get a different number, like a slightly different number, by picking different daily data versus weekly data. You could get another number with monthly data. And so if there aren't any regulations, you can pick the one that gives you the answer you want. If I'm trying to sell something to somebody, then I want to have a low volatility. If I'm trying to sell something to somebody, I want a high drift rate. I don't think this is an ethical thing to do, but I guess it's probably done. You could calculate your drift daily and your standard deviation with monthly data just because that gives you better answers. I don't think that's right, but if there's not a rule against it, you know somebody's doing that. Now let's get to the correlations. Again, if it's not an if, there's going to be an optimize the portfolio question. I could either just give you the correlations between the two stocks as a number, or I could ask you to calculate it. But if I have them to calculate, I'm just use that covariance, and then correlation would just be that covariance scaled by the two variances, right? So, or I could ask for correlation directly with an Excel sheet. So we can calculate. We're talking about the covariance or correlation of the returns. We can calculate those. So even if I didn't give you the numbers, but I gave you the data or told you to go get the data, you would get the data and that would determine these correlations. But notice that these correlations that I got here, so I got the covariance and I got the correlations. Let's go with the correlations because that's the rows. That's the rows that I want to have in my portfolio optimization. So that covariance there, that 0.93, that's the correlation. That's the row between Ford and GM. But that's only for like 10 values. And only for 10 values daily. I hope that when I showed you the monthly stock and we got different drifts and standard deviations, you'll know that if I would have used the monthly and did correlation, I would get a different correlation value there for sure. It's a more involved formula. If the average changes, obviously the correlation is going to change too. What I have here then is, this is the correlation for the last 10 days. And then as I move down, it just keeps updating it. So this is the correlation for the last 10 days. So the point of this is, and here it is graphed, the correlation. Starts off at 0.94. So the point of that graph is that if I pick a different chunk in time, even with the same daily data, I'm getting wildly different answers. In fact, sometimes it's going, I expected them to be positive, right? That 0.93, if someone told me the correlation between Ford and GM was 0.93, I'd probably go, yeah, that makes sense. They both sell big trucks, SUVs. Their fortunes will float together. But there are time spans when you can get quite a bit less than even negative correlation. If I was unethically trying to sell you a portfolio full of these stocks, full of these auto stocks, I would pick I would show you a time span where I got a negative correlation, because that would totally reduce the risk of my portfolio. Right? Because that would make this correlation here a negative number. And that would reduce the overall volatility of my portfolio. So, and it wouldn't, the drift of the portfolio would stay the same. So then you'd be thinking like, wow, this thing's got almost no risk at all. You could never obviously make it a negative risk, but you could lower it quite a bit. Just by choosing the proper time frame. Now this is 10 days, but it looks like I could probably get a month or a 2-month span in here and get a nice negative number to sell you this portfolio. So when we're quoting these correlation numbers, the point of this is the models themselves are built on, I guess this will be like the last thing I say today then, or the last idea. The models themselves are built on all of these assumptions that we know are not exactly true. And worse than that, the numbers we put into them are different depending on what kind of data we take. Monthly data versus daily data, what time span we take, where we take the time span, all of that is giving me different input numbers, parameters, into models that are built on assumptions that we know are wrong. And yet, this is actually what attracted me to this financial modeling in the first place, is that even though this is all built on like shaky, wrong assumptions and parameters that are wildly different depending on when I look, people dump billions of dollars into these things. And if people who have not taken a class like this and don't understand the idea of a correlation, or that the formulas are built on wrong, they just, you grab your HP scientific or HP financial calculator and you type in the stock and the volatility, and it pops out that the option should be worth 60 cents, and you take that as gospel because the machine said so, and it's using a Black-Scholes model for which people got the Nobel Prize, so obviously it's right. Even if the Black-Scholes was right, which we know it's not, the numbers that you type in are not good. So you need to do a lot of different worst case scenarios when you're trying to put your own money into these things. If you're working for someone else, you need to give the salesman or portfolio manager, you need to give them a sunny, good answer that they can sell, and you need to give them a realistic answer that they can prep themselves that something might go wrong, and you need to give them like a super worst case scenario, everything's going to crash answer, so that you're fully telling them what the future could hold. When that expression, all models are wrong, some models are useful, is like so much worse in finance. Right? If you guys have seen physics, like if you're in math modeling class, right? And people doing physics models, they're measuring the bend of a bar. There's a formula for that, and it's not exactly right because it's usually built on classical mechanics, and there's some quantum thing we're not taking into account. But nobody sees that, right? It still works. Bridges still work, even though they're using classical mechanics. But everything behaves so much nicer. Even chemistry, which is kind of wacky, behaves better than finance stuff. What's worse than finance? Behavioral finance, because then you let people into the equation as well. Anyway, questions on what was up here today? All right. So on Thursday, we're watching that movie. When you're watching that movie, and you can watch it at your leisure, you don't have to like haul yourself out of bed at 9:30. I'm going to watch this. I'm going to watch this movie. In fact, some people have already watched it. Look at the back of it's a Nova special on math, so they got to make it. Yeah, they got to make it interesting so you're watching it, right? So there's a lot of the guy standing there and equations are like floating behind him. But these equations that are floating behind him now, you're going to look at it and go, there's page 200, right? Oh, there's the Black-Scholes. You're going to see those things behind. You're going to recognize it. Pay attention to the names in like long-term capital management should be a name that you know. It's a famous screw-up of the stuff we're learning. So when I say about these models like not working, that was like the ultimate not working. But everybody there turned out fine because they got bailed out. So don't worry, they're all still millionaires, billionaires. They're fine. But it should just give you like a caution, a pause with these things. The other thing too there's a lot of walking. I wasn't in that, obviously. I've been in a couple of those things, and it's very uncomfortable. Because
You're an actor.
no, but they go, could you sit on that park bench and look up at the sun? So you sit there and you look up at the sun, right? And then they go, okay, could you walk? And they must have filmed me walking up and down the street like a bunch of times. Walk, walk, walk. And then the guy's yelling, okay, stop. Now look left. Now hold your chin. They have all this like what they want you to look like as you're like inventing something. It's wild to be.
What ones are you?
This stuff for it's PBS Europe for the rumor and counterterrorism stuff. This was years ago, but it was now when I watch them, it's very entertaining because I imagine the guy, because the narration is going over top, so you don't hear the cameraman and the producer lady like yelling at him. Don't look at the camera.
You did a presentation last week on your
Yes.
pirate. Yeah, 'cause I wasn't able to go because I was doing an exam.
Oh, but lots of that stuff, or not, some of that stuff I showed you in math modeling too.
I thought you gave a presentation last week.
To the Pirate Club?
Yeah.
Pirate? Yeah, to Pirate.
IRIT.
Am I pronouncing it correctly? Isn't it